AI Assistant Swagger. Welcome to the interactive Swagger OpenAPI documentation interface for the full Stack AI Assistant API. At the top of the browser view, we observe the primary functional modules including health, authentication, conversations, assistant, platform, and data schemas. Starting inside the health section, expanding the Get endpoint allows us to inspect service availability. Clicking the Try It Out button and executing the request reveals a successful status response with full response, headers, and JSON payload. Moving down to authentication, we examine the post-register endpoint showing required payload fields such as email and password, alongside validation error structures. We then inspect the post-login endpoint, which validates user credentials and returns JWT token bearer tokens. Under the conversation section, we expand the Get endpoint to list all user conversation histories with pagination parameters. Next, we review the Post endpoint designed to instantiate new conversation threads. We then examine the Get endpoint for retrieving specific conversation details by ID, the Patch endpoint for modifying thread titles, and the Delete endpoint for removing conversation instances. Further down in the Assistant section, we expand the Post endpoint used to dispatch user messages directly to the underlying model, inspecting the input parameters and successful status responses. Finally, in the Platform section, we inspect the Get endpoint for environment configurations. We then scroll all the way down to explore the complete set of data definitions, models, and response structures in the Schema section, confirming total API compliance and schema integrity across all endpoints effortlessly now, ensuring full operational reliability and technical excellence throughout the platform. AI Architect Amin Azimi End-to-End System, Azimi Innovation Lab.
Are you ready to see what a production-grade, full-stack AI assistant architecture actually looks like? Welcome to the ultimate backend template built for scalable, asynchronous, and conversational AI applications. At its core, this architecture bridges modern web API speed with robust infrastructure, seamlessly connecting FastAPI, Redis, PostgreSQL, and OpenAI. As we look at the system architecture, the API client communicates directly with FastAPI routes, protected by JWT authentication. Background tasks and workflows are dispatched cleanly to Redis, while domain services manage persistent interactions through async SQL alchemy to PostgreSQL. The layer responsibilities are strictly separated for ultimate maintainability. API routes handle requests. Services execute core business logic. Models define database entities. Schemas manage validation. And infrastructure orchestrates engine sessions and Redis caching. Our technology stack leverages Python with FastAPI for lightning-fast async performance, Pydantic for context validation, PostgreSQL for data persistence, Redis for caching, and Docker Compose to wrap everything into a reproducible local environment. The API surface provides a comprehensive V1 endpoint structure. From health checks and secure user authentication to full conversation management, every endpoint is designed for maximum clarity and interactive Swagger documentation. Looking at the relational data model, user profiles link seamlessly to conversations, which parent individual messages with defined roles and content, all synchronized through unified timestamp mixins. The project structure is clean, modular, and ready for expansion, making setup effortless. With simple terminal commands, you can clone the repository, set environment variables, start the containerized stack with Docker, and run tests instantly. This repository sets the standard for reliable.
Ever wondered how enterprise-grade AI backends achieve bulletproof cloud deployment and zero downtime scaling? Welcome to the live deployment dashboard of our production-ready personal AI assistant hosted on the Render Cloud platform. Right here on the deployment history timeline, you can see complete transparency over every automated build, manual trigger, and commit hash pushed to production over time. Rolling down through the logs confirms an unbroken chain of successful deployments, ensuring complete operational reliability. Opening up the connection panel displays our dedicated outbound IP hosting configuration, essential for setting up secure firewall rules and enterprise database access. We also have direct access to manual deployment tools allowing us to deploy specific commits, clear build caches, or start a service instantaneously whenever updates occur. Navigating into the management sidebar, we gain access to real-time application logs, performance metrics, and system monitoring tools to keep track of backend health under active traffic. Switching over to the core, service settings reveals a meticulously structured backend infrastructure. The application is anchored in Frankfurt, running on an optimized Python environment engineered for high responsiveness and stability. Looking at the build specifications, the system automatically pulls from our primary GitHub repository, executes dependency installation via pip, and serves a live web application using Gunicorn for robust process management. Health check endpoints and auto-deploy webhooks are fully integrated to trigger instant rebuilds upon every code update. Moving into the environment configuration section, security remains our highest priority. Sensitive connection strings, PostgreSQL database credentials, and OpenAI packages are entirely isolated and encrypted within protected environment variables, preventing any exposed secrets in the repository. Returning to the main workspace overview confirms that the service status is active, green, and completely operational. This architecture provides a fully resilient, scalable, and secure foundation for modern AI applications. Brought to you by Amin Azimi, AI architect and end-to-end systems engineer at Azimi